a world encountering catastrophic climate change and natural disasters. Enhancing reaction rates and efficiency is crucial in the production of various essential products. The key component of this process is catalysis, which plays a crucial role in numerous real-world applications, spanning from industrial processes to environmental sustainability. Now, we have a researcher who is endeavoring to elucidate and introduce innovative concepts for catalyst design.
We study reaction mechanism of the catalytic reaction and its applications, especially for CO2 conversion and metal-free catalyst for fuel cell. And also, we study the fundamental mechanism of biological reactions such as enzymatic reaction and mitochondrial respiratory chains. Characteristic of our approach is to use surface science techniques. So the reaction for the electrochemical reactions such as a fuel cell or CO2 conversion of course occurs in liquid phase, but the fundamental mechanism of the surface reaction can be also characterized by the vacuum. So we apply the technique of the vacuum and surface science to know the mechanism of the fuel cell reaction and the CO2 conversion, and also for biological reactions.
Dr. Takeyasu and his team embarked on this research in response to the current climate change that we are currently experiencing.
So for example, currently, the concentration of CO2 is now increasing, and also temperature in the world is also increasing. So that's why we have to cultivate the technology to convert the CO2 to effective materials such as alcohol or formic acid and so on. So that's why we study the reaction mechanism and the application of CO2 conversion. Also, if we see the hydrogen society, we have to consider the usage of hydrogen fuel cell. So currently, platinum catalyst is used for hydrogen fuel cell, but the amount of platinum is not so much in the world. Also, the price is very high. So if we want to decrease the cost of the hydrogen fuel cell vehicles, we have to consider the alternative catalyst for platinum. We are studying the nitrogen-doped carbon catalyst, which doesn't use metal. Then we are studying the fundamental mechanism, reaction mechanism, to activate the performance of the metal-free catalyst, especially nitrogen-doped catalyst.
Catalytic reactions also occur within our own bodies.
So now we have temperatures in our body. For example, we don't know the mechanism of the temperature creation. So we also, that kind of the mechanism of the thermogenesis, so temperature generation in our body, is also related to the reaction mechanism of catalysis in our cells. So that's why we also study the mechanism of the catalytic reaction in biological systems.
This research, along with the insights it provides, has the potential to significantly benefit society by advancing our comprehension of catalytic processes.
A very interesting point is that the knowledge for reaction mechanism for environmental catalysis can be also applied for biological issues and derivation of creatures. So if we can know the basic mechanism of the catalytic reaction, we can not only make the new catalysis or catalytic reaction system, but also to know the important point for human health care, and also we can know the derivation of the creatures in the earth and so on. We have a collaboration with researchers in India, Germany, and Indonesia. So we can promote the collaboration, and then we want to make the new concept for catalytic reaction for biological materials and also for environmental sciences.
In addition to dedicating his research efforts, what vision does Dr. Takeyasu aim to pursue?
So to consider new technology and applications, fundamental knowledge is very important. If we know the fundamental mechanism of the reactions, we can consider all of the environmental sciences, biological issues, and also for derivation of the creatures. So we can enjoy this kind of the fundamental studies.